Alright guys, so this is FBF.1a Learning Target 1.1. Okay, so you're working on taking a story problem and creating a recursive formula from that. So, what that means first is that we understand what that recursive formula looks like. Okay, so remember the recursive formula starts out a sub n equals a sub n minus 1. And we like to do a sub 0 equals. Okay? Now, we could go f of n equals f of n minus 1 and f of 0 equals and use that function notation. Okay? Really, we could also write the next term is equal to the previous term and the let's use the word zero term. The zero term equals. Okay. We could use any one of these in reality. The one we're using more is this one, though. Okay. And so what we need in order to write a recursive equation is we need to know where we start. That's the zero term. Okay. So either the f of 0 equals or the zero term equals or a sub 0 equals. And whatever that starting number is, that's what we put there. And when we think of the starting number, thinking of a table, that's that zero term. Not the first or second, it's the zero term. Whatever that output is right there. And remember, the recursive equation just simply connects the next output with the previous output. Right? That next one down with the previous one, next one down with the previous one. So, we need to start. Then we also need to know how that's growing. Okay, if it's arithmetic, it's addition or subtraction. If it's geometric, it's multiplication. Okay, and we put that multiplication right next to the previous, because whatever is happening to it, we apply that to the previous term, and that's what gives us what we need. Okay, so again, the whole idea is looking for that growth. Common difference in arithmetic, constant ratio in geometric, and where we start, that zero term. And once we've got those two, we just plop it into that situation or even this one. Okay, we definitely want to be beyond that one. But either one of these two I would accept. I'll be writing it more like this one up here, because that's just what we've been doing. So let's take a look at these story problems and see if we can identify where they start and how they grow. Okay, so here we go. So the first one is the super amazing contest of awesomeness has begun in Mr. Reidels's class. The contest is single elimination. There are 59,049 contestants starting the competition. Every day 1/3 will be eliminated. Okay, so again, that idea of where does it start, how does it grow? So reading this one, we should notice that there are this many contestants starting the competition. So I can go a sub 0 equals 5,949. Okay, because that's my starting number, and in a recursive I need that. Then I need to know where my growth is. Well, every day 1/3 will be eliminated. What does that mean? 1/3 will be eliminated. Okay, it means we're going to multiply by 1/3. So that's my growth. That's my constant ratio. Because we're multiplying, this would be a geometric pattern. But it doesn't matter if it's arithmetic or geometric. I'm going to still start out a sub n equals a sub n minus 1 and then times 1/3. Okay, and there's my recursive equation. Again, this part is always going to look the same. We get this for our starting here with the a sub 0, because a sub 0 means the starting, and here's our growth right here. Okay, so let's try number 2. And let's do number 2 if you haven't already tried it on your own, and then you'll probably want to pause this and try some on your own and kind of go through it and see what you get. Okay, kind of use this to help you learn. I don't care about the answers as much as I care that you understand how to get them. Okay, so Ignatius is looking into adding to his Ninja Pony collection. He currently has 273 Ninja Ponies, all different characters, but he would like more. With his allowance, he figures that he can buy 3 every month. Okay. So again, where does it start? How does it grow? So hopefully we noticed this kind of idea of currently. That's kind of our starting point, right? And then he's going to buy 3 every month. That kind of every month should tell us we're growing here. So we're adding 3 more every month. So this is going to be an arithmetic pattern, okay? But I still started out the same. I go a sub 0 equals my start, which was 273. Then a sub n equals a sub n minus 1. And this time we're adding 3. Okay? And that's all I do for my recursive. Okay? Again, doesn't matter if it's geometric or arithmetic. Looking at the a sub n equals a sub n minus 1, right? That helps us fill in this part of the table. The a sub 0 helps us know where we start and then how it grows. Okay? That's the whole point of these. Alright, so probably would be a good idea now to pause it and get to work on some of these, and then kind of use it to check your work, see if you're understanding how to find that starting point, how to find the growth, and then how to plug it into your equation. Okay, and then you could take that recursive equation, make a table with it, make a graph. Once you know where it starts and how it grows, you can do a lot with them. Okay, so pause it, get to work, and then use this video to help you get better. Alright, so let's take a look at the bunch of these and keep on going. So Horatio is saving up for college. He already has $10 in his bank account. He recently scored a new job testing out chairs and will receive $5 for every chair that he tests. Okay, so again, where does it start? How does it grow? Okay, well, he already has $10 in his bank, so that's probably our starting point, right? And then for every chair he tests, he gets $5 more. So that's how it's growing. Okay, we're adding $5 more every chair. Okay, and that's all there is to it. Okay, Bethany likes collecting fingernails. Her collection is growing quite large. She currently has 72 different people's fingernails. She collects, on average, 3 a day. So this idea of currently, she's already starting with 72 right now. And she's collecting about 3 a day. So a sub n equals a sub n minus 1. And we're adding 3 more to it each time. So another arithmetic one. Okay? Alright, number 5. The zombie apocalypse is upon us. The CDC has reported that in the city of Twila there are 50 zombies already, with the population of zombies doubling every hour. Okay, doubling should key you into the fact it's geometric. And mathematically, that means timesing by 2. And we already are told we have 50, so a sub 0 equals 50. Then a sub n equals a sub n minus 1. And times 2. Okay? Now, it doesn't matter if you take this and rearrange them. Okay? As long as you have those 2 parts, though, that does matter. Because if you don't have those 2 parts, then it's not going to work. Okay, number 6. So Gianna is saving up for college. She already has $2 in her bank account. Her job pays $10 per week. So we're starting with $2. It's growing $10 per week. So I can go a sub n equals a sub n minus 1 plus 10, because we're not multiplying by 10. We're just adding 10 more each week. And where did she start out? She started out with $2 in the bank. Okay? So again, it's all coming down to finding that start number and how it is growing. Okay, number 7. Estella starts a YouTube channel depicting Pokemon battles she is involved in online. Her friends and family make 4 followers the first day. Each week she adds 880 followers. Okay, so now this one's kind of a little trickier, right? Because it's 4 followers the first day. So does that mean that's where we started? Like if we're thinking about making a table here, would that be the 0 term or would that be the first term? Okay. And so that's kind of a tough one to determine. But since it says first day, I would probably go with the first term. Okay? And so our growth is she's adding 80 every time. So there's 2 different ways that we can go about dealing with this one. First of all, I know, regardless, a sub n equals a sub n minus 1 plus 80. But the next question is now, do I do a sub 0? Because it's not 4. I would have to go backwards, and technically, mathematically, it would be negative 76. Okay? That doesn't make sense according to the story problem, so there's something else we can also do. I do teach you guys, and I do like you to use a sub 0 for the start when possible, but in some cases, like in this one, a sub 1 equals 4 would be fine too. Okay, telling me that that first term was 4, not the 0 term, because that makes more sense according to the story problem here. Okay, but I would accept either one there. And so sometimes there is that distinction, and if you could argue that, well, you're saying, well, I'm starting with R4 already, so a sub 0 equals 4, you know, I probably would allow that too. Okay. All right. Number 8, Ethelbert is saving up for college. He currently has $400 and is making an additional $30 each week at his new job. So currently $400, so that's our a sub 0. He already started with that. And we're adding 30 each week, another arithmetic, so a sub n equals a sub n minus 1. And we are adding 30. Okay? Alright, number 9, Mr. Radolch's YouTube channel is getting more popular. Last week he had 144 subscribers, and due to the excellent videos he posts, the amount of subscribers is doubling every week. Okay? So last week, that's kind of like where we're starting right now. Okay, because we didn't deal with last week. So that's a sub 0 equals 144. Then I'm doubling. Doubling is my growth, so it's geometric. It's timesing by 2. So a sub n equals a sub n minus 1 times 2. So it's interesting if we look up at number 5 and number 9 together. They both have the same growth. So you'd say, well, are they the same formula? Which for the growth part they are, but it's that starting number that's different. That's what makes these two different problems. Okay, and that's why it's important to have that starting number as well. Okay? Alright, number 10. Ethelbert is saving up for welding school. Man, this Ethelbert is really doing a lot, isn't he? He currently has $400 and is able to triple the amount of money saved up every month. Okay? So that triple, that tells us it's timesing by 3, so geometric. He's starting out with 400. Okay? But his growth is timesing by 3 each time. Okay, again, 10 and 8 look very similar. They have the same starting number, but they're not the same formula because now our growths are different. One's arithmetic, one's geometric. Okay? All right. So that's half of the problems. Okay, hopefully you've been able to get these ones correct. If you haven't been doing it on your own first, you need to try that. So pause the video and get going on this, and yeah, let's keep going. So a cab company charges an initial rate of $2.50 for a ride plus 40 cents for each mile driven. So we start by paying the $2.50, right? That's our a sub 0. It's $2.50 or just 2.5 plus 40 cents for each mile. So every time we drive the next mile, right, we take that previous amount of miles and we're going to add that 40 cents to it. Because for each amount of miles, we're adding another 40 cents. Okay? Number 12, a population of insects doubles every month. This particular population started out with 20 insects. This one's pretty easy to see. We start with 20, right? So a sub 0 equals 20. And we're doubling, so a sub n equals a sub n minus 1 times 2. Okay? Number 13. You and some friends are hiking the Appalachian Trail. You start out with 70 pounds of food for the group, and the group eats about 8 pounds of food each day. So again, we started out with 70, so we have 70 pounds of food, so a sub 0 equals, and we're eating out of that 78 pounds, so we're not adding this time, we're subtracting 8. So a sub n equals a sub n minus 1, and then we subtract by 8. Okay? Same exact idea, just subtraction on this one, still arithmetic, but it's arithmetic subtraction instead of arithmetic addition. All right. Number 14, Maddie borrowed $1,250 from a friend to buy a new TV. Her friend doesn't charge any interest, and Maddie makes $40 payments each month. Okay. So a few different ways that you could look at this one, but we know we started out with that much borrowed. So you could make that positive, okay, as your starting point, saying that's how much she borrowed. Okay, or you could make it negative, saying that's how much she owes. Okay, you could kind of read this one either way. And it won't be wrong, provided we know what to do with this growth. Okay, but regardless, both of them start out this way, right? Then, in this case, where we're going to be chipping away at what she borrowed, so we're going to subtract 40 each month. Okay, whereas this bottom one, it's how much she owes, so she's paying it back, so we'd add 40 each month. Okay, just kind of two different ways of thinking about it, but still same type of problem. Still arithmetic, regardless of whether it's subtraction or addition. All right, number 15. The half-life of rhodium Rh 106 is about 30 seconds. You start with 500 grams. So that one's easy to see our starting, right? Now this one has a lot of numbers, might be more difficult to see the growth. But regardless, I know I'm going to start with that way. Now, if you understand what half-life means, and this is the rhodium number, okay, in 30 seconds, half of it's going to deteriorate. Okay, that's what half-life deals with. It deals with how long it takes things to break down. So, if we started with 500 grams, after the first 30 seconds, it would be down to 250. After the next 30 seconds or a minute, it'd be down to 125. Okay, so this half-life means that we're timesing by a half. So our growth, it's geometric, so we're timesing by a half here. Okay. All right, number 16. A stock is declining at a rate of 25% of its value every 2 weeks. The stock started at $225, so A sub 0 equals $225. I know for my growth for the next term, it's going to equal the previous term. And it's declining at a rate of 25% of its value every 2 weeks. Okay, so what that means is from the previous, we've got to go down 25%. Okay, when we're dealing with percents, it's typically going to be geometric, and declining means that we're going to multiply by it. Okay, but the way to think about it is this. Okay, if my stock stayed the same, it would be at 100%. But every 2 weeks, I'm subtracting 25% of that. So in 2 weeks, I'll only have 75%. So that's what we want to multiply by. We want to say we take our previous number and we multiply by 0.75 or 75%, and that will give us our next value. Okay? Instead of taking the previous amount times them by 25 and then subtracting it from the previous amount, if we just realize that we still only have 75% left over, then we can just start out by multiplying by that 75%, which will get us there. Okay, 17 has another percentage one, so it's going to be pretty similar. So let's keep 16 in view. So the population of a big city is increasing at a rate of 2.5% per year. The city's current population is 67,000. So I know my A sub 0 right off the bat, right? 67,000. I know it's A sub n equals A sub n minus 1. Okay, and just like on 16, we got to do some extra thinking here. So if my population stayed the same, it would stay at 100%. But every year, I'm adding 2.5% to that. So really, my increase is 102.5%. So what I multiply by is 1.025. Okay, that would represent the increase, including the amount that's staying the same. Okay, so kind of tricky, but here we go. Number 18, a Boeing 747 starts out a long flight with about 57,260 gallons of fuel in its tank. The airplane uses an average of 5 gallons of fuel per mile. So we're using 5 gallons, we're subtracting 5 every mile, and we started with that much. So A sub 0 equals 57,260, and A sub n equals A sub n minus 1 minus 5. All right, down to the last two, so hopefully, I'm sure 17 and 16 probably gave you some trouble, but they're the more difficult type. But hopefully you see kind of how to deal with those now. Let's look at 19. A company rents personal watercraft for $70 per hour plus an initial $15 fee. So that initial $15 fee, that's my a sub 0. 70, that's my growth, so a sub 0 equals 15, and a sub n equals a sub n minus 1 plus 70. It's arithmetic there. Now last one, a mole population in your neighborhood quadruples every month. Quadruple, that's definitely our growth, right? So I know a sub n equals a sub n minus 1 times 4. You estimate that there were 8 moles to begin with before you noticed the growth. So a sub 0 equals 8. Okay? So, again, hopefully you see it all comes down to understanding the growth and understanding where it starts. Once you've got that, with recursive equations, everything else is pretty much the same. Okay? We always have a sub 0 equals our 0 term, our start term. We always have a sub n equals a sub n minus 1, plus, minus, multiply, whatever, divide if we need to. Okay? Also remember, like we looked at back here, okay, that a sub 1 sometimes can be used instead. Alright? There we go, guys. Hopefully that has helped you to understand Learning Target 1.1 and that you can now take story problems and create recursive formulas. If you're still struggling, get some extra help and make sure you understand what you're doing, okay?